Good afternoon and welcome to my talk about dismantling Android apps. Before I start, that's the usual slide from the conference organizers, so please do rate this talk. If you think it was the most awesome talk ever, rate it. If you think it was the crappiest talk ever, rate it. This is very helpful information for both the conference organizers and me. Before I dive into the topic of what CodeInspect is all about and why I think all your code belongs to us, so me and my colleagues, I'll give you a short introduction about myself and the research group I come from. So I come from Technische Universität Darmstadt, which is a university in Germany, about 30 kilometers south of Frankfurt, and we do security research. So the subgroup I'm in mostly on applying program analysis to Android for security reasons. Who of you knows about program analysis? Okay, that's a few. For the others, program analysis is creating algorithms and programs that reason about other programs. So you are developers, you write a program, and my programs take that program as input that you give me and say, okay, this is a potential security vulnerability. This is an inconsistency. Here you don't have this access control check that you had over there. Or that say, okay, this is a potential null pointer exception that might be flying around at runtime. And this is especially helpful for security, as we will see. And if you're interested in what we do in the group, then you can also visit our blog. So we occasionally publish vulnerabilities we detected in the Android operating system. We already had a couple of them that were also acknowledged and fixed by Google. And if you're looking for tools, that's also the right place to go. And now, without further ado, let's dive into the content. I think all of you know that. Google Play Store. Who of you has already published an app on the Play Store? Okay, majority, that's great. That means I'm in the right room. So normally when you think about publishing apps on the Play Store, you have a certain model in mind. This model consists of a developer and a user. And usually your idea is that you as a developer, you're the one in power. You have the mighty source code. This means that you can create the app, you can modify it, you can reason about the app, and you're the only one. And the user on the other side just gets the binary code. So all he can do is run the app and nothing else. But what I will show you is, or what I will talk about is, how easy is it for the user to actually gain more power and to dismantle that Android app and say, okay, I want to behave like a developer. I want to know what's going on inside this app. And this is a question not only I am asking, because if you look at Stack Overflow, you find this quite a number of times. So for instance, here's a guy who said that, okay, I've heard that it's very easy to pirate Android apps. Is there anything I can do about it to make it harder for people? Or here's another guy. They complained that only about 5% of all installations of that game were actually paid for. And the other ones were from some shady places on the net and were not being paid for. Or even another one. This guy's also asking, okay, if there's someone determined to pirate my app, exploit security vulnerabilities, do any strange stuff with it, how easy is it for him? So even if he doesn't have the source code, can he do bad things to my app? Can he know what I did in terms of protection and undo it? And this is exactly what I'm talking about. I'm talking about how we can break into your app. So the stuff you do for a living, I'm telling you how to break it. And for that, I'll introduce a new tool called CodeInspect, which is a binary analysis framework for Android. So again, the model is that you have the developer that has the source code, and the user only has the binary code. What we're doing here is we give him a tool that allows him to act as if he had the source code, do the very same stuff. Inject code, remove code, modify code, debug the app, understand what's going on there. And so, what's your first thought when you hear that? Usually people ask me, but why? I mean, I'm standing here. I'm not trying to run away from the police. So why should I kind of break into other people's apps? One answer, because I can. Second answer is there's actually a good reason for it. Because there are legitimate apps where there is usually no reason to break into, and there is malware on the Play Store or on some other stores. So for instance, in China you have app stores that have apps of about 1/3 that are malware. So 1 out of 3 apps is actually something you don't want. And for these things, you also only get the app, but you want to know what these guys are doing. You want to find out, is this app for which I only have the binary code, is this malware? And if so, are they stealing my credit card data? Are they running some premium SMS scam? So sending SMS messages to premium rate numbers at my cost? Or are they actually trying to encrypt my phone and get some ransom for me? So what is this guy? And there it makes sense to kind of break into the malware. And this is the usual process that, for instance, AV companies do, antivirus vendors. Here, just replace the developer by the fraudster and replace the user by the investigator. And then you exactly have this scenario where someone needs to go the development cycle the other way around and reverse engineer an Android app. And that's, in the end, what it's all about, making it easier for the reverse engineer to understand, but also to manipulate. Question, why manipulate? Because sometimes if you just read code, you don't directly understand what it's all about. But if you're, for instance, able to inject a monitor inside there that gives you runtime information, or if you're able to inject additional debugging and logging, this makes it way easier. So as a malware analyst, I sometimes also want to change the malware. Or if there's specific protection in there that tries to hinder me from inspecting the malware, like only do the malicious behavior if you run on a phone located in southern China. I want to get rid of that. I don't want to fly to southern China just to inspect that malware. And this is a quick glimpse of the tool. So the idea is that you have something that looks just like the development environment, with the only difference that it's an analyst's environment. Let me quickly go into over the details here. So who of you knows the old Android developer tools for Eclipse? Okay, quite a few. I know that Android has switched to IntelliJ, but our environment is still based on Eclipse because we started when ADT was still for Eclipse with the first version of their code. So what you do is you can import your binary application into the tool. You get the packages and the class names in your normal hierarchy, just like the developer had. You can look at things like the manifest file to see which components there are. You can look at the assets, see if there is anything hidden. So some malware applications, for instance, they give you a secondary DEX or APK file hidden in the original one, so that if you just look at the outer thing, you don't find the malicious code. But the malicious code is somewhere else. Sometimes it's even in something called a JPEG file that is not actually a JPEG, but that is code. And this is also something you can see here. And I'll show a live demo about that in a minute. Of course, you have the code. Now, this code might not look too familiar to you if you look at it. This code is not Java code and it's not assembly code either. Instead, it's a language called Jimple. Jimple stands somewhere between assembly and normal Java code. Jimple is like Java but simple. And the idea is that if you have a malware developer, he'll try all sorts of stuff to try and prevent this reverse engineering. So he will inject code that you cannot easily get back to Java code. For instance, in Java there is a quite clear semantics to what a loop is. On bytecode, I can create loops that jump everywhere in the code on certain conditions. This is not possible in Java, so I can't possibly get Java code back from such an obfuscated app. And this is why we instead rely on this intermediate representation instead of just going back to Java. Then, as usual for these, for the Eclipse-based tool, there is the code outline. So you actually see what this consists of. You see the fields, you see the methods, and so on. You have the usual thing like syntax errors, because I can also change this code representation. If I want to, if I do something wrong, I want to get alerted about it. I see the output from the logcat, so what the application writes back to me as an analyst. And of course, I can search through it. And this whole thing just looks and feels like Eclipse. For the analyst, this means that it's not too hard to get started reverse engineering Android apps. So you can just obtain the tool and look at your first malware. But for you as a developer, this also means that every guy from the street can just use a tool like this or one of the other competitor tools and say, okay, I take your app that you develop and I reverse engineer it. And so protection against reverse engineering or against all sorts of attacks is more important than ever. And as we have heard in one of the previous talks, there are ways to protect apps. As I'll show you, it's a bit harder, or it's getting harder and harder, because some of the protections we've heard in the previous talks, like checking the signature or doing an emulator check or root check, can actually be bypassed pretty easily. But we'll see that in the live demo. And the most important thing is with these tools you can also debug. Because just looking at a disassembly will not give you the full information about what this app does. What you instead can do here is you can just at any position set a breakpoint and say, okay, I want to know what this binary application is doing here. You have the normal stack trace, you have the variables view, you have all the things you know from normal Java debugging. Logcat, console, all that stuff. So these features are just those that you as a developer are known to, that is available to everyone who just has the APK file. So that was a short intro over the tool. Let me just quickly go over the architecture. I know that this architecture thingy is maybe slightly boring, but I'll do it quickly and then go into the live demo, because I think that will be much more interesting doing live hacking than just going over boring architecture slides. Anyway, so to build a tool like this, what kind of foundation can you use? So this is built on the open source compiler construction framework Soot. Does anybody know it? Okay, so at research conferences usually there are a couple of hands when I mention Soot. This was originally started at McGill University and used to optimize Java bytecode, and has more recently evolved into a compiler and optimization and instrumentation framework also for Android. The idea is you have input formats that can be DEX files, APK files, Java source code files, Java class files, and you can input and output those. So I can easily say, let's take a DEX file, put it into Soot, come back with a Java class file, or take a Java class file and merge it into an APK. So I can just add code to an existing APK. And besides being such a translator, the Soot framework also offers things like giving you a call graph. So showing you for every method call where this goes to or where this can come from. So all the interaction between the methods can just be put into one concise graph by that tool. Or you can also do code synthesis. So if you, for instance, want to say, let's put a logcat print after each statement that accesses my device ID, that's something that you can do with this compiler framework. And since we built on top of the compiler framework, the CodeInspect tool can use all the expressiveness of that framework, which makes it possible to not only have something like Smalley or Bugsmalley that you might know, which just is a translator, but to also have things like powerful visualizations and so on. By the way, who of you knows Smalley Bugsmalley? Quite a few. So this is just a translator from DEX to some human readable code and back to DEX. And we're going beyond that. And this whole Soot framework has been under development by research groups around the world for more than 10 years. Quickly, I told you about that intermediate representation called Jimple. So the idea here is that you have something that is close enough to bytecode that you can represent all the weird stuff that people can do in bytecode, but also be still human readable, which is not the case with things, or not that easily the case with things like Smalley code that is just plain hard to read. And this language can also be used for manipulation. Just a quick, quickly going over that. So this is an actual piece of malware. This comes from the Korea banking Trojan. I'll also use for the live demo, and which I'll go into the details on in just a minute. And what you see here is that this malware actually takes some APK file from the SD card and later on installs it. And this APK file was originally downloaded from a server. So there is a command and control infrastructure here, where the server tells the malware, I've got a new version or some code that you need to execute. The malware downloads the code, puts it on the SD card, reads it in, installs it, and deletes the file from the SD card. And the interesting thing about these modern class of tools, for which CodeInspect is an example, is that they will give you something that has the constant strings here. So even if this originally wasn't a constant, but this was computed somehow, there is a so-called constant propagator and folder running through it that will make sure that even if this was originally a concatenation of SD card and tests somewhere up there, that you will get the string, the full string here, and you as an analyst can easily see it. Another advantage of these modern kinds of tools is that you actually have a typed language. So if you look at things like Smalley code or like disassembly that you get from things like IDA Pro, you only get registers. Here you have actual variable names that are typed as you see on top. So R byte is actually a byte, and this is a file output stream. So it's very easy to read this if you know Java and you spend like 10 minutes going through that code. You have the usual style of first your method declaration, then the variable declarations, and then just the implementation of the method. Actually, this cheat sheet that describes the full language that we use here, if you print it out, it fits on one A4 page. For PowerPoint, I had to split it up onto 3 slides in total. But what I want to show here is simply that this is something that gives you quite a lot of information along the way. So for a field, you see the modifiers, you see the type, you see the field name. For a class, you also see the modifier, you see what it extends, whether it implements an interface. So you get all this information directly like you had in Java. And for the code, the biggest difference to normal Java that you will notice is that the method calls are a bit different. So on the bytecode level, which we're talking here, so where this originally comes from, you don't just have a method call, but you have kind of 4 different method calls. And the 3 most important ones is that it distinguishes between whether you call an interface, a static method, or kind of the normal virtual call. But again, this is if you just want to read the code, then this is still fairly simple. And one other thing we need to take care of when we're talking about something closer to bytecode, there are no blocks. So there is no if then else. Instead, ifs, just as in bytecode, are represented by if this condition holds, then go to there, which is a jump instruction. If not, fall through. Same story for loop. A loop is just a go to with an if. And so these 3 things, loops, conditions, and the split up invoke expressions, they are the biggest difference to normal Java code. Okay, so enough of the boring stuff. I think half of the room is asleep. So let's go to something more interesting that is not just academic stuff, but the real deal. we have analyzed a piece of malware coming from Korea. So if you're looking for funny malware, don't stay in Europe. The much more funny malware you get from places like Russia, Korea, China. There are actually Play stores, as I told you, or Play Store equivalents that serve you 1/3 malware. So just download 10 apps. Usually you get 3 malware apps by just picking randomly. Not good if you want to use them on your productive phone. If you're trying to analyze malware, there you go. This one, they had an app on the market that told you you would get a preview version of the interview movie, and that was before the movie was out. So people downloaded that and said, hey, I get the movie before my neighbor gets it, and I get it for free. And this is all because they are nice people. And there were a lot of users that didn't really think that there might be something slightly wrong with it. And, well, actually there is something wrong with it, because this was by no means the interview movie. This was just a plain old piece of malware. And this infected over 20,000 phones. So there were apparently a lot of people that were keen on getting the movie. If you look at this malware, it's actually a fairly complex piece. So from the user's point, what this does is it first checks whether you have a certain number of Korean banking apps installed on your device. If not, it will just don't do anything. If you have these apps installed, it will impersonate them. So if you're a customer of Bank A and have their app installed, this malware will just look like the user interface of banking app A. If you have B installed, it will look just like banking app B. And they had this implemented for 10 or 12 apps. So someone was actually putting real effort in that. Not in getting the movie, but in getting your bank data. And this malware then had, depending on the bank, they had emulated the security features of the bank. So if your bank had a special, let's say, password for a certificate you had on your phone for accessing your bank account, then this malware would know that and ask you for the password to that certificate. If you're a customer of another bank where you don't need a password for a certificate, it won't ask you for a password for a certificate. So if people have been in the talks here at GoToCon about user interface design, those guys got it right because they knew what to steal from you. And so what did they do? They showed the banking API, asked for username, password, bank account number, the certificate password if required, and a lot of other stuff. And in the background, they had a command and control interface running. So actually, a server could send additional commands to the malware to activate extra features. So, for instance, update this stuff. That's great. We have learned about continuous delivery at GoToCon. These guys do it. Additionally, the command and control server can send an SMS message to that malware to activate SMS message interception. So whatever SMS message you get, it's leaked to the attacker. This is not because the attacker wants to know what your grandmother's telling you about her birthday. This is because you get transaction numbers from your bank via SMS. And that's what the attackers are interested in. And they are also able, if people get suspicious or if police are hunting after them, to disable that again. And then the application will just, well, hide its icon from the launcher and more or less be gone. Another story that we see here, for all this data exfiltration, they use 2 channels. So for stealing your SMS messages, they will send it out via HTTP, but at the same time they will send it out via email because they want to do resilient programming. If something goes wrong, you don't want to disturb the user experience, right? Or the malware experience, because if police is taking down your HTTP server, why stop stealing the stuff? Just go via email. And I think sometimes we as normal programmers can learn quite a bit from malware developers when it comes to things like user interfaces, resilience, and so on. So where did we get this piece of malware from? That was an ongoing collaboration with McAfee, the antivirus company. From their pretest, they knew that this was going on. So there's some email sent and there's some HTTP connection. Now the big question was, where is this data sent to? So what is the email address there? And hopefully, if we get a password, we can then give this password also to the police so that they can check whether there is still stolen data inside the account. And now the big question is, how do you do that? And this is the content of the live demo. So what you usually do is you first have to import the APK file. What I can do is I can just put the APK, or I can attach my phone and import the APK file from the phone. I'm not so keen on running malware on my real phone, so I'll just import the file. And just in normal development environments, I can specify a project name and the file. Since the import takes a while, I've already done that for you because I don't want to waste your time. On the left side here, you see that this is the contents of this piece of malware. So what you see here is, let's go through it. You see the assets. Oh, interesting. There's another APK file. So they don't want us to see all the code. They put a second APK file, and somewhere inside that malware, they're actually loading that additional code. Interesting. You see that there is some native code inside there. So apparently they're trying to hide stuff if we decompile the Dalvik part, or the Android part, and hide it inside native code. Or another interesting thing is, if you look into the resources, they're actually rather good developers, because what they do is they don't just put the user interface strings as normal strings. They use the strings.xml as an abstraction, and they put it all into resources. Maybe in case they want to later translate their malware to Russian or whatnot. So for things like enter password, enter account, they even have proper error messages like, hey, you entered in an invalid password, that's too short. I don't speak Korean, but if you put this into Google Translate, it will tell you something like that. So that's also an interesting story. This malware actually checks whether the data you enter makes sense. If you enter an account number that is not valid for the bank that was originally detected on your phone, they tell you, hey, you mistyped your account number, I'm not going to steal that. Well, they're not showing you the second part of the sentence, but they're showing you, hey, check what you entered. So that's all interesting. Now let's look into the manifest. We see another story that is quite normal for malware. So you see that they request one or another permission. And these are like, I wouldn't say harmful, but let's say interesting permissions like read SMS, read contacts, call phone, read call log. Also very interesting, receive boot completed, because just because the user rebooted his phone, you don't want to stop your scam. Keep the business going. And there's also kill background processes, because if you detect the original banking app, you of course don't want the user to use the original banking app, but you want him to use the malware. And if you go through that, let's just see where to start, because usually these apps are rather large. So let's see if we have something like main here. Or, nah, even better. Let's go for what is in the launcher, right? And you find something that is called MainActivity. That is good. Never mind the package name. This was chosen by the malware developers. They are funny people. They name packages like this. Now let's go to the definition. And there's an onCreate. Let's look into this for a second. So first of all, you will see that there's actually a lot of code, but there's already something interesting, right? There is something called get banks info. So as I told you, they're checking which bank you're a customer of. They don't want to scam the wrong bank. They have things like the bank URL. And, oops, here we go. There is something that looks like a username and a password here. So this is our first candidate for that email access. Remember, they were stealing your data also via email, and we were interested in getting the username and password for that. So probably we should set a breakpoint inside this method and see what's happening here. Now let's just do that. Yeah, this is the normal debug configuration thingy from Eclipse. Only thing is I'm debugging on a binary now, not on source code. and I want to use my emulator here, I could also start a new emulator or a real device. But running malware on real devices is a rather bad idea, so I won't do it. So waiting for debugger to settle. Aha, it's asking me whether I want to open the debug perspective. Sure, I do. Okay, so this is essentially a super call. That's nothing too interesting. Let's go further. Now they call a method that is called isE, and they store the result in something called Z0, and the result is true. What we see here is if Z0 is true, we go to label 3. Let's see what label 3 is. Oops, that's killing the app. So the question is, why does the malware just try to kill my app? And so let's just look into this isE, because apparently isE made the app kill itself. And if you look in here, that's interesting. They get the mobile info and the phone state, and then they check whether this contains strings such as goldfish, SDK, Android. Does anyone have a clue what this could be? Yeah, this is an emulator detector. So we saw that this the return value was true, of course, because I'm running on an emulator. But I don't want the app to die because I want to continue my investigation here. So let's just fix that. There should be. Z0, okay? Nah, I'm not running on an emulator. Sorry. Yep, here we go. Z0 is false. Jump over it. No, it's not an emulator. These aren't the droids you're looking for. Okay, let's just go over all the garbage here. We were interested in whatever they were doing with that password or username or what business. Okay, so what they do is they call a method called string user here. Just give it a try and see where this comes from. Oh, this actually comes from native. So this is exactly what this native library was for, because this string user and string password, these were native functions. So they're trying to hide the username and password from us by just putting it in native. But we're in a debugger, so let's say this variable string is the outcome of this call. So they put it in native, but it's of not much use, because I can just see the value here. And this has been taken down now, so don't try to steal the account data and sell it on the black market. It's down. Same story if we step on and look for the password. Here we go. So even if you put things into native code, they're not gone. They're simply there. Put a debugger and that's it. Now, before we go on, let me just make one change, because I know that I will forget this emulator check at some point during the demo. So let's get rid of it for good. I just comment it out, save the project. It says building workspace. Here we go. Emulator check is completely gone. So I don't have to fiddle around with this no, I'm not an emulator thingy. Now, what we haven't found yet is where they actually sent this email, right? What we can do here is, at some point, these guys steal SMS messages, right? So we can see whether they actually use this receive SMS. Here we go. So this is an intent filter for SMS received. Let's just see where this goes. Yeah, this is an intent filter for a hell of a lot of stuff. Never mind. Let's go into that. Once again, malware developers are interesting people. They seem to like 4-letter words. I don't know why. Okay, so there is an onReceive method. And once again, what I can do here is I can simply set a breakpoint. So I need to run my app again. Yeah, same old emulator. Yeah, installing, launching, connecting debugger. Okay, I Forgot to put out the breakpoint in onCreate in main. Okay. And now, of course, this is intercepting SMS messages. So let's send it an SMS message. Let's say it's coming from 4242 and it's an SMS saying, hello, GOTO Con. Let's just send it. That is, yeah, okay, I didn't activate it. So the interesting thing about this is, that, as I told you, there is a feature that enables you to activate and deactivate the SMS stealing. If we go back into the code, we can see that pretty simply. This activation and deactivation thingy is controlled by getting the first the phone number. So this will only accept phone numbers that start with 86 or 82, which are the country codes for Korea and China. And then they do some funny parsing here, and what they do is, where are we? Yeah, they check for a command called AK40. Don't ask me why they named it this one. And if you send a message with a correct telephone number, so plus 46 or plus 42 something, and AK40_1, it will enable the SMS stealing. AK40_0, it will disable the SMS stealing. And in case the app gets restarted, it's good practice to save it, right? Persistent state. So they just use shared preferences and save it as SMS status. Don't make the attacker send the status twice. That's a bad user experience. You want to avoid this. So now let's just start that one again and send it the magic activation SMS message. Yeah, by the way, you might be wondering why there isn't an error coming through. This is a pretty simple thing because it says unknown host exception, cannot resolve host, this one. First of all, I'm in an emulator, so this has no internet connection. And secondly, police tend to take down malware hosts, so this is just not resolvable anymore. That's also one of the things you have to deal with when looking into malware. Sometimes these hosts are not reachable anymore, or there is some other funny behavior going on. Okay, for this one, we were looking for plus 82, right? Plus 82, so let's just do plus 82. I'll just send this here. Oops. Oh. Okay. Yeah, that's apparently a new one. Anyway, so this will usually just make the debugger hit that breakpoint and show you the incoming SMS message, and they will write this value into shared preferences. Also interesting is that you find calls to abort broadcast. What this does is, if this message is actually coming from your bank, they want to, make it differently. If you want to contact your bank and say, hey, I think there's something wrong, or if your bank wants to contact you and say, okay, your account has been hacked, you want to disable this because you don't want the people to be warned about the malware. So what the developers actually did here, the malware writers, they aborted incoming phone calls and SMS messages coming from the bank so that people aren't warned. Interestingly, there was a bug inside there. So the original version of the malware, they aborted also incoming phone calls from other people, not only from the bank. This is a bit unfortunate, but you see that sometimes malware developers aren't good developers either, so I guess they should have put in more testing, some regression tests, some JUnit tests, should have fixed the stuff. So if there are malware developers among you, do test your code before rollout. That might actually hinder your scam if you're doing it wrong. Now let's just quickly go into the, in the interest of time, let's just quickly go into the actual scamming parts. You see this call here to post JSON. So this is doing the HTTP sending part, and I think it was inside 3. There is the actual mail send, and if I set a breakpoint here and run the app once again, which I won't do in the interest of time, you will see that this was the very password that we saw when we debugged the onCreate. And you also see the contents of your incoming SMS messages being stolen here. I think that's enough for the live demo. Let me just go back to the slides. So you have seen that the tools like this can be very helpful for inspecting malware. If you're a malware writer, times are getting harder for you. But also for software development, sometimes you have a library of which you only have the binary code, but not the source code, but something's crashing in your app when you use the library. With these tools, you can just debug inside the library and see what the real cause is and how you can get that fixed. You can look for security vulnerabilities inside these libraries. And you can see what happens under the hood, so you can understand these libraries better. Of course, don't be evil. So copyright laws still apply. These tools can be used to steal intellectual property from other people's apps. For instance, a nice algorithm, reverse engineer it, copy it. Possible, but illegal. Or you remove licensing checks. Assume you have an app in the Play Store that is free, but if you want to, let's say, play more than 3 levels in the game, you have to pay for it. If this is simply a check, hey, if I'm paid, I can comment it out. It takes me about a minute. Still, it's illegal, but possible. And if you want to protect your app, keep that in mind. So simple checks like this emulator in the malware example, they won't do it anymore. I guess we've talked about most of that. So my claim is all your code belongs to us. So all apps are essentially open source in one way or another, as we have seen. Never hide secrets in the app code. So credentials for backends, encryption keys, just don't hide it there because it's visible to everybody. And if you release an app, it's totally simple to piggyback malware inside there. You have seen the code, you have seen that I could change the code. I could have also injected malware. It's simple. And cracking paid apps is also rather simple. One more concrete thing. We have conducted a study on Backend as a Service providers. So you know what Backend as a Service is? Okay, so there are people that don't run their own backends. They rent it off Amazon or whatnot. We have looked into how people access these backends, and usually they hardcode their username and password. We will present that study at Black Hat in Europe in Amsterdam in November. Interesting is we found in total over 80 million records and more than 56 million individual data items that were accessible just through the credentials that were openly available inside apps. We conducted that study together with the respective providers, so we are in contact with Amazon or Facebook, who owns parse.com. So this is not just some shady hacky business we do on the side. We cooperate with the vendors to close these gaps. And these are not just gaps in the backends. These are things that developers got wrong. They threw their credentials to the world by putting them into the malware. Or yeah, we have seen malware, but also goodware with these vulnerabilities. What we got there? These records, there were email addresses, health records, employee databases, customer support databases. We have seen full server backups residing there, or also voice records of car crashes. So please, if you store sensitive data, privacy sensitive data, whatever, do not put your credentials inside the app, or else the data is just gone. And we've seen cases where an attacker could actually manipulate the data. So increase your own salary or whatever you want. Countermeasures. In one of the previous talks, we've heard of you. So string encryption. Doesn't help too much because you can still use the debugger, and when the string is used, it has to be decrypted in memory. For string encryption, when the string is finally used, it still has to be available in memory. So then just set a breakpoint and run off with a string. Code encryption. Well, at some point the code must be decrypted. Put a breakpoint and access the file before it's loaded. Hide calls and reflection. Well, I might not be seeing from the code where this call is going because it's a reflective call with a weird string. But I can use the step into feature and arrive in the right method. Or debugger detection. Just like the emulator detection in the malware, we patch it out. I think I only got a couple of minutes left, so one thing I want to show is the plugin system. So one of the plugins we have for this tool is Data Flow Analyzer. So this will automatically tell you which data is read and where the data is sent to. And this can also help you analyze such a piece of malware by saying, okay, this reads from here and writes to here. For instance, in that case, you see that this is the source, this is a sync method, and the data is flowing along the arrows. And in the CodeInspect UI, this is just a list of the data flows and the propagation path along which the data is shown in the program. For instance, here you see the source method. You click on it, you see all the statements involved in propagating the data, and you can jump to the code where this happens. And this is also one of the things we can use for looking into malware. We were working on more plugins like automatic deobfuscation, reconstructing encrypted runtime values fully automatically, and much more. Maybe I can show you this in a future edition of GoTo. One thing that might be interesting for a few of you is how you can get the tool. We're currently looking into commercializing the product, so we're a university, which means that the basic technology is free and open source, and it's all on GitHub. The UI is not. But you can send me an email and get a free 60-day license. That's no problem. So with that, let me end the talk. I hope you had a bit of fun and learned something about investigating malware applications. And remember to rate that session. Thank you.
Okay, thank you very much, Stephen. You actually answered a lot of the questions that came in during the last slides. I just have one question for you. You mentioned something about Android Studio. Is it something that you're working on, getting CodeInspect to run in Android Studio? Or?
Well, this is some of the core problems of academic research. You don't get people to do the engineering task or the boring stuff. So we started this in Eclipse, and I'm afraid it will stay in Eclipse for most of the current time or the more recent time, because we just don't have developers that explicitly work on product features. We have researchers, we have student assistants, but they want to do the cool stuff. They want to do the hacking, the reverse engineering. So just this thing like going to a new platform is something that's rather hard for us to do.
Thank you. Yeah, I think that's about it. Time's up. So thank you again.
Yeah, thank you for having me here.